I wish you a good day and just have a any kind of words you can say to your friends. I wish you a good future and good grades in your you already divide into groups, so I will not divide it, okay? It's formal. So I just want to revise. So it will take around 5-6 minutes. So let's take like your first, okay? Then you'll try to answer. What type of fuels do you know or remember from the first? Coal, wood, wait, the first group is answering. Coal, wood, what else? Oil. Natural gas. So let's check. It's correct. It's coal, wood, and oil. Of course, you can add some of them, but in general, you are right. So I'm just taking like 1 point, okay? Give 1 point, and I will summarize at the end. Next, the second, you are the second, okay? So what is the combustion of fuel just in general? Carbon, hydrogen, sulfur, oxygen, nitrogen. So just in general, how do you understand in word like combustion? Do you want to help the next third group? Yes,
Combustion of fuel means burning fuel.
Complex chemical substances. Okay, but entailed chemical reaction
With oxygen.
with oxygen. With oxygen, you are saying together, but with oxygen it was detailed, okay? The fourth group will take 1 point, so let's check with the oxygen. Carbon with oxygen, okay? The next, the third question to your group, to Madina groups. What is the difference between complete and incomplete combustion? The main difference. Yes,
The difference between complete and incomplete. Complete releases carbon dioxide, water.
Yes. The first difference. What about incomplete?
Incomplete releases like monoxide, carbon monoxide.
Carbon monoxide.
Yes, and it's very dangerous.
Yep. So that was the main difference between them, if you remember. Difference between them, incomplete carbon dioxide will be released. In incomplete, only carbon dioxide, also carbon monoxide will be released. As the main difference, okay? So the last question to the Madina. Yeah, Madina Sayajan. What gases are called greenhouse gases? Who remembers? Madina Sayajan. If you don't remember it, so others can help. Greenhouse gases. So let's check. Yes, you are right. 2 points first group: methane, carbon dioxide, and water vapor. Great. So the last one I want to mention about combustible and non-combustible. What is the difference between them? Combustible, when they produce heat and light. Okay? And for example, you are burning something, for example, wood, paper, and after that they produce heat and light, this specific point. This is known as combustible substances. But another one, this is known as non-combustible substances. This is a diversely that don't undergo combustion in the presence of air. So it means even there is air, they don't produce heat and light. Okay? So I want to show. So let me give 1 second. Sorry, students. Actually, I couldn't find much, so I just wanted to show them. But okay, just let's predict and I will show it then. Okay. So first, for example, we have wood or cardboard. We have glass. The second one, iron nail. You know it? What is iron nail? Yeah. Glass and then cardboard, or you can say like wood. Okay. So how do you think? What will be burning? The first one, the wood or gas? Just from your opinion. What first will be burned? Wood or gas? Wood, yes. Okay. So when you, for example, when you burn this wood, it, as you know, it produces heat and light. But compared to glass, even there will be heating up, but there is no any light compared to wood. Okay, the main difference. So now look to the literacy question. I'll give it now. In the course book literacy question. Yeah. So now try to answer in pairs. What is the combustible and what is the non-combustible? In pairs, okay? So you can work in search. This one. Okay, guys. So just one by one, as you finish. The first one, paper. How is it combustible or non-combustible? Combustible, yes. Okay, it's right actually. Charcoal, the meaning is or it's combustible. What about iron nail? Non-combustible because it takes a long time and of course there is not producing any light. What about gas? Give to the combustible. Non-combustible. Great. Kerosene oil, your turn. Combustible because it is fuel. As you see, there is are known as combustible. What about stone? Non-combustible, it's too hard. And the last one, plastic. Combustible. Great. Now let's check. Is it right?
Yes.
Great. This is all of them combustible. Now let's start the new topic today. So first of all, look to the pictures. We have two different pictures that's showing ice. The first one, the second one showing us fire. So what is the difference between them? What do you see there?
Ice is melting and the heat is
Fire is also you can see the direction here. There is it means they produce energy, producing heat. And while in the ice, they need to what? Take or absorb heat to melt ice. So today your topic is exothermic and endothermic reactions. So you can write down the topic, today's topic, exothermic and endothermic reactions. The 6.2, the page 46. Exothermic and endothermic reactions. Okay? So today's your objectives is you need to know why combustion is exothermic and some of them are endothermic. Okay? You need to first to know the differences. The second one, you need to evaluate the capacities of fuels and its effects on the environment. So two main objectives you need to understand. Now look to the, let's revise the previous grades. If you remember, we have chemical reactions. So the main signs that there is occurring chemical reactions. Who remembers that there is occurring chemical reactions? Changing color. Yes, you are right. For example, from the colorless to pink color is already chemical reaction. What else? Composition. Composition will be changed. And this is third one, close to S, will be changed as a chemical reaction. Color, composition, and then change smell. Smell, yeah, odor, smell. Now let's check. So you are already right. There should be first a color change, odor change. Odor means like smelling changes, like gas evaporation, evolution, formation. So the next one, there should be formation of precipitation. I hope you remember what is precipitation? This insoluble substance, yes? Also, the absorbing heat. Generating, like producing or absorbing heat is also chemical reaction. So it means burning of woods or like melting of ice is also the chemical reaction. Okay?
and also changing shape.
Changing shape. Students, I will check. Now write down this shortly. So chemical reactions, as a thermal chemical reactions, divide into two of them: exothermic and the endothermic. Exothermic and endothermic. So exo, it means outer. Okay, they are producing heat to out, while endo means like into. So it means they are absorbing heat into the, for example, specific system. So write down the shortly, then we'll do the task together. exothermic and endothermic. So if you see, to show that there is exothermic reaction occurring, just you need to show that pi plus Q. Plus Q means heat is releasing, producing. While endothermic, it will show you more like minus Q. Minus it means absorbing the heat. Okay. So for example, in this reaction, this is the combustion reaction by showing that there is a produced energy and heat, Y plus Q. So you can identify easily that this is exothermic reaction. And the next one, this is endothermic reaction. This is also endothermic, but the heat is absorbing in this case by showing minus Q. So you can easily identify that this is endothermic reaction. Okay? Just look into the sign, it's easy to differentiate between the reactions. Okay? So have you finished? So if your friend have finished, you can look to your friend's paper. Okay? Plus Q and minus Q. The main different signs. So guys, in shortly you can like memorize, like endo it means inwards, like absorbing, exo it means outwards, like producing. So I gave you a paper. If you see, in pairs I gave you a paper. So first look to the questions. What is the exothermic reaction? What is the endothermic? And then give examples for each of the reactions. So first you need to watch the video. After watching the video, you need to find the right answers. Okay? Now, let me. Wait, sorry.
In this video, we're going to look at exothermic and endothermic reactions. So what are they? How are they different? What about their energy levels? In the next couple of minutes, you'll know everything you need to get started. An exothermic reaction gives off energy to the surroundings, like this fire giving off heat. Whereas an endothermic reaction takes in energy from its surroundings, like this cool melting snowman taking in the heat. Just remember, exo means external, so giving out. And endo means internal, so taking in. Let's start by having a quick look. Because exothermic reactions transfer energy to the surroundings, and this energy is usually heat energy, they cause the surroundings to heat up, just like a bonfire, keeping it warm low. Other examples of exothermic reactions are neutralization reactions between acids and alkalis, reactions between water and calcium oxide, and respiration. It is easy to detect exothermic reactions. Just get your thermometer and see if the temperature increases. Watch the hydrochloric acid and sodium hydroxide being how it's thermometer. Both reactions are exothermic because heat is given up. Physical processes can also be endothermic or exothermic. When something freezes, it goes from liquid to solid. Bonds need to be made for this to happen. And to make bonds, you need to do some work. Thus energy is given out and freezing is exothermic. Similarly, when condensation happens, because the gas is going to liquid, again bonds need to be made. And so energy is given out. So freezing and condensation are both exothermic. Because of exothermic reactions, energy is given out to the surroundings. This means that energy of the reactants is higher, and the energy of the products, hence the energy curve of the exothermic reactions, always like this. Now let's have a look at endothermic reactions. These are their smaller ones. Remember that endothermic reactions take in energy from the surroundings. Again, as with exothermic reactions, the energy being transferred is usually heat. So endothermic reactions, the surroundings usually get because the temperature would be cooler. Some examples of endothermic reactions are electrolysis, the reaction between sodium carbonate and ethanoic acid, separated into endothermic reactions can also be seen in two processes. When something melts, it goes from a solid to a liquid. For this to happen, bonds need to be broken. And to break bonds, energy needs to be put in. Like our melting snow now. Boiling is also a
So it's enough. Sorry for the voice, but let's try to answer by yourself. So what is the exothermic reaction? In your words, you can add yourself. Okay, the first group.
When something produce give out heat, like wood burning, fire.
Yeah, like outward producing something energy heat. Yes, you're right. The next, what is the endothermic reaction? Others, wait, let's give, yes, consider, or
taking energy from the exothermic reaction.
or you can say like from the outside, yes, from the outside into the world, like inward the system. Can you give the examples for the thermic? Yes, melting of snow. Or what else? Who can ask? Melting of ice.
Melting of ice
Ice cream, like something ice cube, yes?
Yeah.
That's cold. So by like absorbing heat cold. Yeah, something cold. What else? What about photosynthesis? Photosynthesis process.
because they take energy from the sun.
Yeah. So not only ice cubes, also that the something that takes energy, light for the usage. That's also known as endothermic. And the last one, the examples for exothermic reaction.
Fire,
sun.
something gives energy.
Something gives energy. Yes, you're right. As if, for example, burning of wood, burning of paper, they give energy to the outside, to the outward. That's why this is exothermic reaction. Great. So students, now, so open the page. The literature lab work. So first, read the text carefully. First one, read the materials procedure. Okay, so what is saying there? So now we are trying to find the difference between exothermic and endothermic reaction. Yes. So we need to I just some of them displaced or replaced by the citric acid and the sodium bicarbonate. Okay. So the first one, let's try to figure out two beakers. Okay. So we have first beaker and second beaker. So the first beaker, there's already added the citric acid taken from the lemon juice. Okay, this is simple lemon juice. So what is now to lemon juice? First of all, let's firstly measure the temperature. So I'm measuring the temperature of the lemon juice. Or you can also use this one, two of them. Wait. Together, let's add together. Let's wait. 24. Okay, 24. This showing also 24. So now I'm adding to this citric acid, sodium bicarbonate, or simple our baking soda. 3 spoons. 1, 2. Wait, it's enough actually. Actually, you know this reaction?
Yeah.
So just wait. Okay, it's okay if it's exploded. Citric acid, lemon juice. Okay, lemon juice. So now I'm again recording the temperature. The first one, so can you write one of them, the temperature, initial temperature, and the second one? Initial was 24, and what is happening? Is increasing or decreasing? Increasing. Okay, actually you need to wait some time, around 5-10 minutes. So I'm checking also with the second one. This always decreasing as 22. Okay, actually if you wait at around 10-15 minutes, it should be decreased. So now the seconds, our experiments, I'm adding hydrogen peroxide. Okay, the simple medical one, hydrogen peroxide. So now let's again measure the temperature. This hydrogen peroxide 26. Okay, 26. Can you write? The second 26 initial temperature. Now I'm adding your simple yeast. Yeah, simple is. How do you see what happens when you add hydrogen peroxide? Is the temperature increased? You think decrease will be increased? Okay. Okay. I'll just add by eye. So now let's wait. It takes more time, but it's also what's happening, rising. So this process, all you can see in when you're baking, for example, any dark kind of. So let's wait. Now let's record our. So what is happening?
Increase.
It's increased. It was at first what temperature? 26. Now it's already increasing. 28. Actually, you can already increase even to 50 if it's already like added enough. So you need to also like wait around 5 minutes for the 69. So let's again record with this second thermometer. It's also increasing. So already stopped at 38. So you can write like 38. 38, right? Yeah. Write down. So students, now to your paper, write down like the first reaction. Do you remember what was the first one? Yeah. When you add citric acid, like let's say write like C acid, okay? Plus what you add sodium bicarbonate or our baking soda. So in first and the second one. Second we added is with hydrogen peroxide, yes? With hydrogen peroxide. So you need to finish the last report as a homework, okay? I'll give you to finish the reaction. So just let's firstly write the temperature. In first, what is the initial temperature? Was 24, and this final temperature 22 degrees. Yes. What about the second one? Initially was 26 and 28 degrees. Now look to the temperature. Now let's predict what reaction is endothermic and what reaction is exothermic? How do you think? The second one, temperature is decreasing. What's happening there? Endothermic. First one is endothermic. Let me write this. Endo. Second endo. And there is exothermic.
Increase the temperature.
Yep.
Значит, көтерілмей ма?
No, like from the outside they are taking, but inside they are like taking energy and decreasing as temperature. So this is exothermic. Exothermic, okay? So what conclusion you can make from this one? When you look to this temperature and to the experiments reaction, what conclusion you can make? Okay. Exothermic. Okay. So just by simply seeing the changing of temperature, you can conclude that is it exothermic or endothermic reaction. Okay. So guys, I'll give it the homework. You need to finish the writing the reaction. Okay. Like writing reactants, products. So don't forget to write this one. Don't forget to write the topic, the objectives, procedure, materials. And the last one, I will check the homework, observation, and questions. So you need to answer the questions like step by step. So for example, which is exothermic, endothermic, how do you understand? And at the end, you need to write the conclusion one. Okay? Okay. So the last point I want to mention is about fuel efficiency. If you remember, from the previous lesson, we had about fuel, different types of fuels. So, for example, we have different fuels today are used mostly ethanol, gasoline, kerosene, so different of them. So, for example, 1 kilogram of fuel, they produce a specific amount of energy, yes?
Yeah.
So, for example, now look to this table. We have different types of fuels, and this is known as like for 1 kilogram, there is 1 kilogram they are producing, for example, 54 joule energy, and the set price approximately according to 2017. So now, in your groups, discuss what fuel is more efficient compared with these fuels. So I'll give you 2 minutes. In groups, try to find which is more efficient and try to give the answer. No, also don't forget to look to the price. Okay, I finished. Students, now let's take the literacy as a homework. Okay, as a homework. Wait. Okay, let me give you 1 minute. Let me give you 1 minute, then I will. What students now write down what did you learn and what problem do you have?
Okay.
One problem and what did you learn?
Teacher, we don't have a problem.
Any kind of. It's okay. Students, what did you learn? What did you learn and what problem you have? Two of them. What did you learn and what question or problem you have? If you have finished, take your paper here. So I will
Evet ya, tabii doğasına öyle.
and record your stickers. Okay, so let me have this one. By the way, students, literacy and lab work